and other things, how to virtualize the cloud environments using the cloud SIEM. Then we will discuss what are the prerequisites required here. Then we discuss the how to use the cloud SIEM with the Eclipse, means we integrate the cloud SIEM simulation toolkit with the Eclipse to virtualize the cloud environment. Then we discuss the practical example of cloud SIEM. So we are going to start. So first we understand the what is the cloud computing. So here the basically cloud computing deliver the computing resources and services to the user as per their requirements. So what happened here? Basically in the cloud environment, a user requests for particular services from the service providers. So service provider is providing the requested services to the users. So basically cloud computing is all about the services. So it considers the software as a services, platform as a services, and infrastructure as a services. So here we are showing the various vendors. So you can see the vendors here for that provide the cloud computing services. For example, Netflix is providing the video streaming as a services. Spotify is providing the music for audio streaming as a services. And the Facebook, Yahoo, and Twitter and LinkedIn are providing the social media as a services in the cloud environments. And for storage purpose, storage as a service, there is a rack space, Elastic Cloud Computing 2, and Dropbox. These is provide the storage as a service in the cloud environments. So basically, cloud computing is a leading technology for delivering the reliable, secure, fault-tolerant, sustainable, and scalable computing services. So it is a fault tolerance and reliable means it is available the all time. If some server are not available or some data is corrupted, so it can be recovered the data from the different instances because it can maintain the multiple instance of the same data on the different servers. If some server is down, so user can access the cloud services from the any other servers, right? Sir, am I audible? Actually, I can't listen
Yes,
you.
sir. Yes,
That's
sir.
why I'm
Yes.
asking. Okay, okay.
Yes. Audible.
So these are the basic service models used in the cloud environment. So in the service model, there is a software as a service, platform as a service, and infrastructure as a service. In the software as a service, a user can be access the remote software from their own machines. And the platform as a service that provide the execution environment. So these environment you can access, for example, Google app is you can access and can be implement your program in the Google environments. So this is a platform as a service. And in the infrastructure as a service, provide the network bandwidth and storage as a service in these infrastructure as a service. So user can access the requested services from their local own machines. So these are the various deployment models used in the cloud environments. So basically the private cloud. Private cloud is a cloud which is accessible to the some specific peoples. Some specific people can be accessed in the, so for example, in the intranet, in the single organization. And community cloud is connected the multiple organization for the same purpose. For example, music streaming as a service can be accessed. So multiple organization can be accessed in this community. And the public cloud is accessible to all public user of the cloud. And hybrid cloud is a mixture of public and private cloud, which can be a provide the publicly and some specific services is provided to some specific private users. So now we are learn about the what is the virtualization. So virtualization, we can mimic the something. Okay, so this is a virtual version of something. So basically, it provides multiple operating system, supports the multiple operating system. That means the ability to run the multiple OS, single physical machines, and that is accessible from the anywhere. You can access via the PUT or IP address and port address to access the uh, uh, servers, virtual machines from the different places at the same time in ubiquitous manner. So in the virtualization also support the sharing of instances. Exactly what happens in the servers. if some applications is running in the server, so these applications instances is created. So every instance is used by the different users. So that allow the sharing of the single physical instance of applications or resources among the multiple organization or tenants. It also improves the IT throughput and profit. So by using of the physical resources as a pool from which virtual resources can be allocated. That means for some resources are shared between the users, right? So these resources can be fully utilized. For example, one CPU used by the multiple people, so that can be a multiple tasks running on these CPUs. So it can be fully utilized by the multiple users. So there is a no free space. So it can be provide generate the high throughput and make the profit. We do not require the multiple uh, system for the single user. We can be a single user can be shared by the multiple users. So in the virtualization, there is a one term is used the VMM. That is a basically hypervisor, or we can say that it is a virtual machine monitor or virtual manager that manages or provided the how to interact with the hardware and virtualization operating systems, just like a guest OS. So it provides the just a interface between the guest OS and hardware. So it separates the computing environment from the actual physical infrastructures. So this is the basically what is the concept behind the virtualization. So here a creation of virtual machines over the existing operating system and hardware. So what happened here basically three entities use the host machine, guest machine and hypervisor. Host machine that means the machine on which the virtual machine is created. Okay. There is a one physical machine. There is a you can create the multiple instances of the virtual machines, and these machines can be accessed for different purpose for different users at the same time. So here, what is the guest machine? Guest machine is a virtual machines, or we can set the VMs in short. It referred as the guest machine. So in the single host machine, we can create the multiple guest machines or multiple VMs. Or there is a hypervisor, so it acts as a virtual machine monitor and manager. It manages the virtualization thing. So just like an interface, how to interact with the hardware. So it's a program that allows multiple operating system to share a single hardware host. So in the diagram, we can see that there is a virtualization layer is there, virtualization platform. You can use the any virtual hypervisor. That is a Zen, KVM, VMware, anything. So here the different distinct isolated VMs is created on the single machine based on their power and capabilities. So these VMs is separately executed there on the host machine. And now this VM, what happened in this VM? For example, first VM contain the Linux operating system, second VM contain the Windows operating system, third VM contain the Mac operating system. So you can run the different operating system on the host machine. Host machine can be, you can set that there is a two type of hypervisor is used. I will explain in the coming slides. So in the hypervisor, you can create the VM with the different operating system. So it is a virtual machine is isolated runtime environment, guest OS and applications. And multiple virtual systems, VMs, can be run on a single physical system. So there you can see the two hypervisor st structure is here. So in the type 1 hypervisor, there is a base layer, you can see that is a hardware layer. So you can place the virtualization layer that is called the hypervisor. So this hypervisor layer is directly on the top of hardware. And in the hypervisor layer provide the virtualizations where the multiple virtual machines are created on the this hypervisor layer. So you can see the virtual machine 1 is here. That is containing the some guest operating system and applications. Then virtual machine 2 containing the another guest operating system and applications. But that are directly run on the host machine or hardware or bare metals. But you can see in the type 2 hypervisor that is typically installed on the top of an existing operating system, and it's called a hosted hypervisor. Means you require the operating system to virtualize the providing the virtual services. So here you can see the hardware layer, then host operating system. Operating system may be a Windows, maybe a Linux, right? So there is a your own application, system application also running, and in the parallel, you can also install the hypervisor. Hypervisor is some software that provide the virtualization here. So basically, we are using the type 2 hypervisor for testing purpose. For VMware, we are using the VMware VirtualBox, and that is you can see the hypervisor layer containing the multiple virtual machines. Here in the diagram, you can see the VM1, VM2 is there that contain the operating system and applications. So you can see the some example here. So here you can see the type 1 is an example. There is a KVM is a kernel based virtual machines, Microsoft Hypervisor 5 servers, VMware Fusion, Windows Virtual PC and VMware Workstation are the example of type 1 that is directly installed on the bare metal. And type 2 hypervisor is a required the some host OS. So it is a working on the top of host or operating system. So this is example of the QEMU, that is a quick emulator. Other is a Oracle virtual machines. Another is a VMware. Another is a Virtual Logic VLX and RTS hypervisor. These are the example of type 1 and type 2 hypervisors that provide the virtualization in cloud environment. So what is the benefits of virtualization? So first one is the cost reduction, because the sharing of the resources, so a single resources can be used shared between the multiple users, so it can be a fully utilized, so it reduces the cost. Isolation means there is a virtual machine are isolated from each other as if they are physically separated. So a single host machine contains the multiple operating systems. So every operating system is distinctly isolated from each other. So you can be implement differently in just like a sandbox. Next is a hardware independence. Virtual machines run independently of underlying hardware. Then portability. So when you performing the migrations of the virtual machines between the hosts, so you can easily migrate from one host to another host because the host contain the multiple virtual machines. If you want to move the one host from the one system, one host to another application, so it can be a migrate from one system to another system and can be a reinitiate easily. It is a more flexible and efficient allocation of resources that leads to a better resource utilization and increase the performance. It can be a remotely access and provide the rapid scalability. So we can be remotely accessed via the software like Putty. So there is a high availability and disaster recovery. So that supports the fault tolerance and reliability. So it can be always available in case of some server down, some data unavailability is there. So that support the pay-per-use model because it is used inside the cloud, and cloud is provide the pay-per-use services. You can pay according to use services, and also provide the on-demand services based on the user request. It enables the running multiple operating systems. So we can in the start I will say that you can create the multiple operating system and that can be accessible from the different locations. So these are the various type of virtualization provided in the cloud environment. So that is for example the applications virtualizations. So in the application virtualization, that helps to a user to access an application from the remote server. Just create the two different versions of the same software and access from the different users. And the network virtualization is the ability to run the multiple virtual network with each has a separate control and data plan. So create the virtual provisioning of virtual, just for example, switches, firewalls, load balancer, all contained in the network. You can virtually access these things. In the desktop virtualization, it allows to user can be a operating system to be remotely stored on the servers, and you can access the your desktop from the server. And in the storage virtualization is just a process of grouping of physical storage from the multiple network storage devices. So it look like single storage device, means multiple systems are combined into a single system. So we don't know where is the data is stored, but we can use as a single physical machine from our machines. For example, in the case of we using the data center, so we store our data in the data centers. So we don't know where is the data is stored on these machines. That is a responsibility of the service provider, how they store our data. But we know our data is stored in the single place, but that is in the background, that is stored in the distributed way and across the data centers. Now basically we are learning about the how to virtualize the cloud environment, how to we can see the how cloud is working, what happen in the cloud environment. So just we can take the feeling of the cloud, we can use the cloud sim environment. So what is the cloud sim? Basically cloud sim is a framework for modeling and simulation of cloud computing infrastructures and services. So that is called the virtualized cloud environments. Means you can virtually feel that how cloud is work, and that is implemented in the Java programming language. So it is a tool for modeling the large scale virtualized cloud environment, which has components for creating data centers, host, virtual machines, brokers, and service requests. It allows a developer to run any server hardware model as a software simulation to analyze its behavior for real world workloads. So in this environment, you can create the requirement of what amount of task you want to execute on the virtual machines, number of hosts you required, number of virtual machines you required on the particular host. You can set the all policy requirement from the broker, and data center provide the requested services to you, and you can analyze the performance of your applications. So it is a very easy to use and easy to extend, because cloud sim is an extensible simulation toolkit. You can extend every classes of the cloud sim according to your use. You can also create the new classes for their use. So here there is a on demand up and down allocation of VM resources is there. So the basically cloud computing is elastic in nature. So it provides the resources as per the requirement. It can be resource quantities increase or decrease as per the request. So such as the resources like RAM, bandwidth, and processing element is called the cores or CPUs. Now the test the performance of newly developed application services. So in the for the developer, if they want to deploy their services in the real environment, before they can be a test in this simulation environment to analyze the performance output of their applications. So Cloud SIM is developed in the cloud computing and distributed system, that is Clouds Laboratory, at the Computer Science and Software Engineering Department of University of Melbourne. Nowadays, this cloud sim toolkit is introduced by the Rodrigo and Rajkumar Bhuiya and their teams. So this lab is now currently handled by the Rajkumar Bhuiya. He is the director of cloud laboratory in the University of Melbourne. So basically, these cloud sim supports the core functionality of cloud, just like you can create the task, queuing of task, and providing the way of scheduling of task. Next is the processing of events. So in the Cloud SIM toolkit, you can see that everything is happen on the basis of events. So events are triggered by the tag value is used in the Cloud SIM toolkit. So it identified the tag value and corresponding function called based on these events. So in the cloud sim environment, there is a multiple classes is there, and every classes are interact each other using the events. Here, the creation of cloud entities. So the cloud entities, you can say that there is a data center broker, and other data center, etc. That promotes the communication between the different entities. So multiple entities are communicated each other using the events that also support the broker policies and other policies. You can also VM provisioning policies, CPU provisioning policies, RAM bandwidth provision policies. Though many policies is supported by the Cloud SIM toolkit. So this is the Cloud SIM basically structure is there where the some different layer are for different purpose. So here the network layer is supporting the network topology and message delay calculation purpose. Cloud resources is basically event perform the event handling based on the tag values. It supports the coordination between the clouds and data centers. Then cloud services, so there's a different provisioning and allocation policies based on the for the virtual machines, CPUs, memories, storage, and bandwidth. So it is defined the order in which the task is executed and bandwidth or memory is allocated to systems. Now next one is a VM services. So in the VM services, there is some handle the what are the services for the cloudlet and VM and manage services. And the user interface, there is a basically broker or user can be interact. So that mention that the how many number of cloudlet required, how many virtual machine are required, and user can also send the cloudlet to the virtual machine which cloudlet is used or execute on which virtual machine. So it can be a mention by the broker or user before submitting the request to the data center or bro. Okay. So now the user can access the services based on their requirement. So basically, for before starting the cloud sim, there is a prerequisite is there the basic understanding of how to program in Java, because this simulation toolkit is implemented in the Java language, programming language. So you must be aware about the Java. And the next thing is the some basic concept of orientation concepts. So how to use Cloud SIM with Eclipse. So we are going to integrate the Eclipse with the Cloud SIM. So you need to be first set the development environment. So and this simulation toolkit use the Java. So you need to download the JDK Java development kit and install first to make the development environment. Then we try to integrate the Cloud SIM with Eclipse. So when we are going to integrate the Cloud SIM, we need to set the path of Cloud SIM folder in the Eclipse and enable the all required libraries for to run the Cloud SIM packages. So these are the downloading links is given for the some prerequisite is there. So first we are going to the download the Cloud SIM. So basically we can download the 2.1 version 2.0.3 as per your requirement. There is a small modification in the various version of the Cloud SIM. So we can download the Cloud SIM that contain source code examples, jar files, APIs, and HTML files. So these are the link is given where you can download the Cloud SIM. Next is a download the math library. So there is a common math library is provided by the Apache. So you can download the this is the library from these links. And another is the you need to be download the Eclipse for Java developer. So you can run easily integrate and run the Cloud SIM toolkit. Next, you need to be download the Java development kit. This is a development environment for building the applications, applets, and components using the Java programming languages. So these are the links is given here. So I will show you how to download the packages. So I'm going to set the web browser here. Now you can see that. Are you able to see my web browser?
Yes, sir, it's visible.
Yeah. So this
Uh,
is the URL where you can download CloudSIM toolkit. There is a many version of the CloudSIM. So the basically start from the 2.1. So we can be normally consider when you are first time using the CloudSIM toolkit, you should be a download the 2.1 version. Otherwise, you can download the most stable version is that is a 3.03.
Vikas, sir, sorry to interrupt you.
Yes, sir.
Sir, actually, I just want to know, could we use NetBean also with CloudSIM?
Yeah, sir. You can use the NetBean also, but for in the NetBean, you need to be a ART compiler for compiling the source files if you can change in the source file. So there is a additional work is there. You need to be every time if you uh, write the single sentence or single word in the source file, you need to compile whole CloudSIM packages by the ART compiler. So there is a,
Okay.
some additional work is required in admin. Therefore, we are using the Eclipse.
Okay, so it would be better than we use Eclipse. Okay, sir, thank you.
Yeah. So there is a no other additional work is required. It is directly compiled. Okay. So this is the link of downloading the CloudSIM 3.03. You can right click and download this. Next is we need to be download the math library from the this URL. URL is given in the PPT. You can paste here in the browser. So there is you can see the URLs here. So basically we can download the latest one is a binary zip file from here. So you can click here to download the common.mat file. So that is a support for mathematical operations performed in the Java. The next you need to be download the Eclipse for Java developers. So you just type on the browser download Eclipse for Java developer and you go with the link and just download the Eclipse packages, right? You click here download and download. I have already downloaded, so I'm not really download this. Next thing is you need to be download the Java development environment. Basically, Eclipse is run Eclipse or NetBeans. You need to be first set the environment path or Java development kit JRE environment, build the JRE environment. So here you can download the JDK. JDK you can download from here for your operating system. You either you are using the Linux, Mac OS, or Windows operating. So these are the downloading prerequisites. Links is given in the PPT. You can follow the links and download the packages, right? For creating the environment of CloudSIM. So now I am going to continue the presentation. So basically, I'm explaining the basic cloud simulation environment. So I'm repeatedly tell that the cloud sim is an extensible simulation toolkit. You can extend according to your use. So there is a multiple core classes and classes exist in the cloud sim toolkits that enable the modeling and simulation of cloud computing system and application provisioning environments. So where you can implement the cloud your applications and extend the cloud simulation toolkit. It is a basic toolkit. You can enable the security things in also here. So you can propose a new security class in the cloud sim. So you can provide the security things. You can provide the storage as a service applications. So you can extend according to your use. So there is a multi-component of the cloud. Here you can see the data center is there, broker is there, virtual machines is there, CPU is there, and resource provisioning policies. These are the component of the cloud. So CloudSIM implements the core entities that simulate resources, information services, statistics, shutdown services. So that is initiate and flush the some components and other entities as the cloud simulation environments. So they also provide the interaction between the entities through the events. So event is handled through the tag value is used in cloud sim environments. So here events are used for service request and service delivery purpose. So basically main three component of cloud model are used. So basically for provide how to understand the how cloud sim is work. So you can see there is a user, broker and data center. There is a three entities. So first one is a user is the client or customer who want to access the services of the cloud. So
Sir,
it
please share your
requests.
slide. Sir, slide is
Okay,
not visible.
okay, so sorry for that. I'm sorry. Now slide is visible.
Yes, yes, sir, it's visible.
Yeah, yeah. So so I already explained the what is the component here and how the core entities interact with the events. Now there is a main three component of cloud sim model is there. So here user, broker and data center three component of the cloud sim model. Basically we can see the how it is work in. So user is the client or customer who want to access the services of the cloud. Broker is act as a mediator between the data center and service user and service provider. So data center is basically here the service or resource provider. So user and data centers interacting through the broker. So now you can see in the diagram there is a client requesting particular services to the broker. Now broker is the forward request to the cloud data centers to provide the particular requested services of the users. Now cloud data center is reply the service to the broker and broker is print their services and reply to the clients. So this is the general architecture, how the entities are interacting with each other in the cloud sim environment. So now I'm what is the steps to perform the simulation in cloud sim environments. So first I will go to the explain the steps, then I'm going to explain the what are the syntax used in the cloud environment. Then I will practically example, so the practical examples, how the practical example is performed in the cloud environments. So in the first step, there is some initialization the cloud packages. It should be called before creating any entity. So we have to going to the initialize the cloud sim environments, initiate the all entities and components. Then in the second step, we are going to create the data centers. Basically, data center are the resource provider in the cloud sim. So we need at least one of them to run the cloud simulation. So we need to create at least one data center because the data center is contain the host is contained in the processing elements or number of cores is there where you can create the virtual machines that is the accessed by the users. So now we have created at least one data center here in the second step. In the third step, we have going to create the broker because the broker is forward the policy is required, the how many virtual machines is required, how many cloudlets are required. So it is a all request create the request and broker is forwarded to the data centers for getting the services. So we need to in third step create the brokers. In the fourth step, we have going to create the virtual machines. So we prepare the list of virtual machines required for execution of our task. So here, first we need to create the virtual machines, then add into the virtual machine list. So we have a complete list of virtual machines. Now this list is going to submit to the VM broker. So we finally prepare the list of requirements and then submit to the broker for the virtual machines request. In the fifth step, there is a you need to be create a cloudlets. So how can you create the cloudlets? First, I will show the syntax in the coming slides. So first you need to be create the cloudlets, then add these cloudlets to the list. Then they submit this list to the broker. So finally, you can see that you have the two lists. One is the virtual machine list and another is the cloudlet list. So basically, cloudlet in the cloud sim environment is just like a task or job you want to execute on the remote machines. So basically, you are here creating the list of jobs or list of tasks where you want to execute on the particular virtual machines. So how do we bind the cloudlet or task to the virtual machine? So there is a some module function is given in the cloud sim environment that allow to the bind the cloudlets to the VM. This way the broker will submit the bound cloudlets to only to the specific VM. So here you can bound the cloud. Otherwise, the cloud sim is handled automatically on first come first serve basis, or you can bind the cloudlet to VM, so you can predefine decide that this VM is this cloudlet or task is executing this particular VM as per your created the VM. So in the next step is the start the simulation. Start the simulation is the initiate the all the entities and component of the cloud sim environments. Everything data center is ready, broker is ready, everything is ready for starting the simulation and execute the simulation. When you click the stop simulation, it stops the simulation and all the entities and components. In the final step, it print the results when simulation is over. Okay, so when we are going to the see the practical example, we will see the all how these steps is working. So these are the basic syntax are used. I'm going to explain the basic syntax used in this simulation toolkit. So now in the Java, if you want to create the array list, so how can you create the array list? So this is the syntax of creating the array list. So you first define the int list. It's an integer type list. There is an integer is a class. So init is the object of the list of integer type. So now new is a call the constructor of the array list class and create the list of integer type. So this is the basic syntax for integer. Just like this, we are using in the cloud sim for cloudlet and virtual machines. So here, how to create the cloudlet list? So there is a, you can see the, first we create the cloudlet list of cloud type. There is a cloudlet is a class in the simulation environment. So there is a, we define the, just like integer, we define the cloudlet. So we create the cloudlet list of cloudlet type and then create using call the new for constructor of the array list of cloudlet type, and there is a we can create the cloudlet list here for collecting the cloudlet or task in the cloud sim environment. So for collecting the virtual machine in the cloud sim environment, we have created the VM list. So here VM list is a type of VM. VM is a class in the cloud sim environments. So we create the VM list is VM type. So basically there is an object, we are storing the object of the VM in the VM list. So this is the basic syntax of the how to create the list of cloudlet and virtual machines. Now the steps is how to initialize the cloud sim. So basically cloud sim.init is a function in the cloud sim toolkit. So there is a getting the three arguments. First one is the number of users, means there is a, in case of cloud sim environment, there is a number of broker is called the number of user. If there is a one broker, so you can set the number of user is one. If there is a two broker, you can set the number of user is two. There is another is a calendar class is used for particular getting the time and date from the instances. So it is basically for uh, printing the execution time of the particular task. And then next one is a boolean trace flag. Basically it is not in use, that is by default it is false. It can be used in future purpose according to your requirement, because cloud sim is an extensible simulation toolkit. So once you initialize the cloud sim, then next is the syntax for creating virtual machines. So basically virtual machines, for creation of virtual machine, we require some predefined information. For example, we set the what is the ID of virtual machines. So here the VM ID is 0. Then set the million instruction per second is the processing speed is required for particular VM. VM is just like a operating system we are defining on the for the remote storage. So this is the configuration of these virtual machines. Ki what are the requirements to run the VM on the remote servers. So there is another is a size is defined. That is basically is the amount of storage in the MB is defined here. Then we define the RAM required in the MB. Here the 512 RAM is defined, 1024 defined according to your use. Then you are going to define the bandwidth, how much bandwidth is required, how much processing element. Page number is a processing element, number of CPUs, or you can set the number of cores required to execute your task. And there another is the you can define the VMM is a virtual machine monitor or hypervisor. So you can set the name of the hypervisor or you are going to use in this cloud sim environment. Basically, it is a just kind of a string. There is the no effect. You can change the any to you can create your own class according to hypervisor, so that can be changes in the final results of execution time. So it basically is in cloud sim is implemented on the basis of the Zen hypervisor, so it printing the results according to that. So if you are going to change the string of Zen, it also working the same. So here, how to create the VM? So there is a VM class is in the cloud sim environments. We have created the VM1 is the object of this VM class, and using the new keyword for initializing the construct, executing the constructor of the VM class. So this value is passed to the VM module. Their first value is a VM ID, then broker ID, which broker is accessing. Which broker want the request for this VM creation of this VM. So we need to be set the broker ID, set the processing speed which is in the MIPS, then set the processing element number of elements means number of cores is required, then set the how many RAM is required, then bandwidth, then size, amount of storage required on the remote machine, then set the hypervisor, which hypervisor is required for providing the virtualization. Then finally it send the cloud scheduler, type of cloud scheduler. So there basically two type of scheduler are used in the cloud environment. There is a time scheduler, time shared and space shared. I will explain in next coming slides what is the difference between the time shared and space shared. So now we are going to know about how to create the cloudlet. So for the cloudlet is the job or task in the cloud sim environment. So here we have first initiate configure the required informations to create the cloudlet. So here you can see the ID of cloudlet is we defined the 0. The length of cloudlet means a number of instruction want to execute in the cloud sim environment. So there is a cloudlet length defined in the MI, and the file size we required the file size before starting the simulation, what amount of file size is required. Output size is required after finishing for writing purpose, so that is a 300 byte is defined here. Then you can set the utilization model, which utilization model is you are going to use. So basically utilization model is a scheduling policy, how to schedule the task, or how there's a sequence or ordering of the task providing. For example, by default cloud sim using the first come first serve basis. So you can be used just like shortage of first, longest of first. You can modify the classes of the cloud sim according to your use. So by default it is for support the first come first serve. Now this is the syntax of how cloud sim is created. So here you can see the cloudlet is the class and cloudlet1 is the object of this class. Now in the next new keyword is called the constructor of this cloudlet class with the base. This argument is passed in this constructor. So there is a, you can see the ID. First we pass the ID of the cloudlet or task, then length of object is required, how many instruction executed, and then processing number of processing element is a page number, and file size, and you have to output size and some utilization model. Up there is, you can see there is a 3 utilization model is given here. So what happened here? So 3 utilization model, first for the CPU, second one is for the RAM provisioning policies for how to utilize the RAM, and then third one is for the bandwidth. So there is a for CPU bandwidth and RAM, for there is we are using the 3 utilization model for different purpose. So by default all are using the first come first serve basis. Now we are going to set the integrate the cloudlet to the particular broker, which broker is generate for this cloudlet. So you can set the user ID here. So you can tie up the cloudlet one to the broker one, tie up the cloudlet to the broker two. This is the syntax, basic syntax, how to set the integrate the broker and cloudlet in the cloud environment. So basically, how to bind the cloudlet to VM. If you want to perform the execution of particular task on particular virtual machines, so you can use this syntax. This is a bind cloudlet to VM. Here you can see the cloudlet ID and virtual machine ID. So you need to pass the ID of both cloudlet and virtual machines. So this cloudlet is bind to these virtual machines. So when the cloud simulation is running, so this cloudlet is executed in this particular VM. So the syntax is basically inside the broker class. So we can create this broker is the object of broker class dot bind cloudlet to VM function is defined inside the broker class. That we pass the how do we get the ID of, so we here write the cloudlet one dot get cloudlet ID and VM one dot get VM ID. This is a function is used to bind the particular task to the particular virtual machines. Now we are discussing about the what write a function with the parameter to create the host in data center. So we are going to create the host. Yeah.
Actually, sir, I have a question. The length of cloud. So the previous slide and one
This
more,
one.
sir. Yes, sir. So the length of the cloudlet, the size is mi. So, sir, what is the mi? What is the meaning of mi? That is micro instruction.
It's a million instruction. There's
Okay.
basically is a length means how many instruction are executing during this for this cloudlet particular
So it is the
cloudlet.
maximum length. You can execute 4,000, 40,000 million million instructions.
Instructions in this, but instruction size is not defined here in the simulation environment. You can define, you can extend the simulation toolkit according to your use. By default, there you taking some integer variable and some default time.
Okay, one more
So
question, sir. Yes, actually,
yeah,
this is the question for me, which is very disturbing me in the cloud scene.
oh
Actually, sir,
yeah,
I
yeah.
just want to create. Okay, sir, is there any tool through which we can generate our output generator graphs, which is obtained by our cloud simulation?
Actually, you know that the cloud sim is an extensible toolkit. So there is a lots of extension is available in the internet. So there is just like a cloud analyst or this kind of things.
No, sir,
So
actually, I've
you
used
can,
cloud analyst, but I am not able to access that. Okay, sir, we will when while you practically, then I will take help from you, sir.
yeah, you can contact me anytime. Yeah.
Okay, sir. Okay, thank you.
Okay. Welcome. So here, how to create the host in the data centers. So there is a, you can define the pre-configuration. So host ID is 0, RAM is 2048, and storage size is itne required, itne bandwidth is defined, MIPS is the million instruction per seconds. So this is the requirement for creating the host ID. So before host ID, because the host contain the multiple processing element or multiple cores, means one system contain the multiple, there's a dual core is contain two cores. So just kind of we are creating the cores. So first we need to prepare the list of cores or list of processing elements. That is the give the input to the host machine to how many cores is created inside the host machine. So here, first we create the processing element list is PE list. So add function is add the new processing element inside the processing element list. So here P is the class for processing element. There is a, you can pass the ID, and there is a pass the provisioning policy with the particular uh, million instruction per second speed of the processor. Now this prepared this P list. So you can see this P list is given into the host constructor here, P list. So in the host constructor, there is a, we need to pass the host ID, RAM provisioning policies. They have called the function of the RAM provisioning policy plus constructor. Then bandwidth provisioning, simple is passing the bandwidth, required bandwidth at the particular host. Then passing the storage space is required, processing list of the processing element and the scheduler. So there you can, two type of scheduler is there, space shared and time shared. So basically used for our this purpose. So time, if you define the time shared, there is a multiple task execute in this host OS. But if you are going to be a space shared, there is a one task run at a time on the processing elements, because this is not allowed the sharing of processing elements in space shared. I will explain in the upcoming slides what is the difference between space shared and time shared. So we are going to see the practical example of Cloud SIEM. So before going to the practical example of Cloud SIEM, I will explain you the what is the scheduling policy in the task execution. So there is a space shared, means there is a one class is used. There is a VM scheduler space shared. Um, so here VM allocation policy used in the space shared. It means that only one VM is allowed to run on each piece, and there is no sharing between the processing elements, right? But in the time shared, you can the parallel run the task. So there is allowed the sharing of the processing elements. So you can see that the is the VMM allocation policy that allocate one or more processing element to the virtual machines and allow the sharing of processing element by multiple virtual machines. This class also implement 10% performance degradation due to the VM migration. So here there's some, I used some example from the research paper of Rajkumar Bhuja, the how the space shared and time shared is performed. So here you can see that the effect of different scheduling policies in the task execution. So first one, A, you can see the in the diagram A, there is a space shared for VM and tasks. So both VM and task are space shared. You can see there first VM is separated from the second VM. So that is a spatially shared. And you can see there is a two cores is there. In the first core, there is a two tasks, T1 and T2 is separately executed. Okay, so there is a no sharing between, no parallel processing between the tasks. Same here, T2 and T4 is executed in the core 2 of VM1. Just here you can see the tasks T6 and T8 is executed on the core 2 of the VM2. So here task and virtual machine both are spatially shared. In the second example, you can see the virtual machines are space shared, but the tasks are time shared. Means you can see the two VM are separately defined with the two cores. So here you can see the T1 and T2 are running the parallel. Means that is a time shared execution of the task. And you can see the T3 and T4 in the core 2 of VM1 are running the parallel in the virtual machine 1. The same you can see the in the virtual machine 2, there in the core 1, T5 and T6 are running the parallel in time shared manner. And T7 and T8 are running in core 2 of virtual machine 2 in the time shared manner. So in the diagram 3, there is a, you can see in this diagram C, there is a time share for virtual machines and space share for tasks. Now you can see there is a virtual machine are sharing running in the core 1. You can see the VM1 and VM2 both are running parallelly, right? So here, but tasks are executing separately. T1 and T3 are executing in V1 of core 1, and task T5 and T7 are executing in the core VM2 core 1 of the virtual machine 2. So this is the similar for the core 2 is given here. So these tasks are space shared and virtual machine are time shared. And the last diagram, you can see both virtual machine and task are the time shared. You can see in the core one, VM1 and VM2 both are executing parallel. That is a time shared. And T1 and T2 task in the VM1 of the core 1, you can see the both are running parallel. That is a time shared task. Similar to the VM2, T5 and T6 are running parallel. Similar in the core 2. So you can see the example of what is the space shared and time shared and how they execute. So I am going to show you the practical examples of the Cloud SIM environment and how to set up the Cloud SIM. So I'm going to share the. Hello, sir. Am I audible?
Yes, sir.
Yeah, sir. Can you guide me? How can I share my for showing the practical example of Cloud SIM? How to set up the environment? So there is no option for sharing the.
Your computer is visible, sir.
Yeah. So just a minute, sir. You can see my drive folder computer screen.
No, sir, it's blank now.
No, sir. Blank.
We are,
So
sir, share your browser.
yeah, I can share, but there's a Cloud SIM toolkit is installed in my system, so I want to share my screen of my system. So I will show the how to configure the Cloud SIM and what are the examples of Cloud SIM.
Actually, sir, we have I discussed, we have all download all the files. You just start the sir, Cloud SIM. So start the clips, and then we follow the process. How you can add the jar files and all the things we can easily understand through the Eclipse. So you can just open the Eclipse and share your Eclipse, sir.
Okay, okay. Now
Hello.
Eclipse is visible to all of you.
Yes, yes. This is
Yeah,
visible
yeah.
now.
So for creating the new project, you need to be create on the file and create on the new, and here you can select the new Java project, right? So here you can put your any name of the for the Java projects, for example, Cloud SIM test. So I just write the Cloud SIM test, and we need to be select the path of the Cloud SIM here. So I'm just going to extract the Cloud SIM jar file in the particular directory, Now I'm going to select the Cloud SIM package from the drive. So here I am selecting the Cloud SIM 3. That is the packet, unjar packet of the downloaded Cloud SIM. We select here. Now we can create on the finish. So here you can see that now this project is creating, taking some time. Now you can see there, here is a Cloud SIM test is created, right? So it is working, taking some time. Now it is going to complete around the 74% is completed. Is so now till now we are understanding the what is the Cloud SIM, what is virtualization, how to virtualize the cloud environment using the Cloud SIM simulation toolkit, and their syntaxes, how to create the cloudlets, how to create the virtual machines, and how to create the data centers, and how to submit the cloudlet to the brokers. So we have seen the all of the things, and now we are going to perform some testing, some example how the Cloud SIM is running and what are the results generated from the Cloud SIM toolkits. So it taking some time. I don't know how it time taking. Yeah, actually it is taking too much time, so I'm going to close these and start the existing environment.
Sir, how to add a jar file and maths file in Eclipse?
You just click on the, actually, I will show you, but there is a taking some time. So you just need to be click or right click on this created project, and where is you can see the option of including the jar files. Yeah, now project is created. Yeah. So there is a, you just need to click right click on the this cloud sim test, and there is a pro, click on
How
the
to get the
property.
Java Eclipse, sir? How to get this window?
Yeah, just you click on the Eclipse, so you get this window. And now we have select the in the file in the new Java projects, where we select the path of Cloud Sim, or name the Cloud Sim as a Cloud Sim test, right? So this Cloud Sim folder is created. You can see here in the package explorer. So you need to include the additional math Java RAR files we downloaded already downloaded. So we need to import here. You just click on the property. Now here just click on the Java build path. There is some libraries you can see the already exist in the CloudSim folder. When you downloading the CloudSim folder, this jar file is content that, and you need to be add the external jar. You click here the add the external jar. So the and jar file this sim, you just click OK. Now Now you can see the error is removed and Cloud Sim is completely set up. So here you can see the various example is given in the Cloud Sim toolkit. So these are the basic example given for the how to perform the simulation. This is the example of how to perform the networking examples. So I will show the example one here. Yeah, just you can see the example. So before starting the example, I just click on the run and test the example is working or not. So if this working means this is the simulation environment is completely set up. So it taking some time.
So, sir, JRE environment must be kept in the same folder of Cloud SIM. The all four R4 files must be in Cloud SIM folder.
No. You just need to, we downloaded the JDK for the Java runtime environment. So that is a cloud Java development kit. You just double click on that and install the just like a normal here. Okay.
No, no, sir. Actually,
And then
I have Java. I'm working with Java, but as I add to the library, so it shows that unbound.
basically you just download the JDK. JDK contains the JRE in all supporting libraries of Java. So you
So
rather
I
than
have JDK,
JRE,
sir. Sir,
you
actually,
just download.
I have JDK, sir, in my system. I run the program
Okay,
of Java also.
okay. So basically only we need the JDK. So this is working on that. You just download at least for Java development purpose. Okay, so that is the working.
So I need to download JDK for.
For JDK, you need to download at least for Java development purpose.
No, sir, I have downloaded the Eclipse. Eclipse is working.
Okay, Eclipse is working, then no problem.
So, but the in Java build path, as I click on Java build path and go to the library, so there is a cross symbol that is, and it shows the JRE system library Java SC 1.7 unbound.
So you need to be set the compiler. You create the project, you can change the compiler ID. You are using old version of JDK or GID. So upgrade your version of the JDK and then
Okay,
it can be really running. Okay.
okay, sir.
So
Okay,
that is the
okay.
version problem, right? So we are going to run this example here. So we can see the output. So starting the Cloud SIM example one. Just using all the objects we have seen in the step one. Then it is same version of the sim which we are running the 3.0 version. Then it is creating the data center is starting. This is the data center 0 is the name of the data center, but IDs from the data center has 2. Means IDs start from 2, but name is the data center 0. We pass this example. Then is starting means entity is initiated here. And clouds list receive one resources. You can see here. So because in one cloudlet is created, one virtual created, and one is assigned to center 0, that is the ID is hash 2 because data center name is underscore 0 but ID is 2, and host IDs start from the 0 2. So there is in the one data center there one host is created. So here you can see the sending cloudlet 0 to the cloud virtual machine 0. Now cloudlet 0 is received at the broker. uh, Now this is a simulation is completed. So all cloudlet executed are finished and destroying the VM. So in the cloud is elastic in nature. So once we created the resources and once the work is completed, we need to be shut down properly, shut down all the resources. So here you can see the destroying the VMs and broker is shutting down. No more future events is exist. So they maintain the event queue. His name is the future event queue. So there is a no event in the future event queue. So it's completely shut down and notified to the all cloud sim entity for shutdown. So data center 0 is going to shut down, broker is going to shut down, and simulation is completed. There is a 2 time printed. The simulation is complete, one from the data center, one from the broker. Now you can see the output. You can see the cloudlet 0 status success executed on the data center ID 2. Cloudlet ID is 0. Total execution time is 400. Start time is 0.1 and finish time is 400.1. Right. So we are going to see the example. So I
Sir,
will
what
show
will happen if you increase the number of users, sir?
increase the number of user. That means that you can create the multiple broker inside there. For example, here you create the one broker, right? This is the broker
Yeah, okay.
created. If you create the two brokers, so there is a two number of users is there. Okay, so that is a requirement. You initialize the cloud sim environment. So you first define the number of broker is there. User means broker in cloud sim environment, right?
Okay. Generally, you are taking only one broker, sir.
No, no. I will show another example. There is a two broker or multiple broker is there. So don't worry about. I will tell you that
Okay.
in the example 4, I think in the example 4, there is a number in the 5. You can see here the number of user is 2, right? And you can see
Yes.
that there is a two broker is here, right?
Yeah, okay.
So you need to define before the starting simulation. So I'm going to explain the example 1 here. So we prepare the cloudlet list here. We prepare the virtual machine list here. Then we start in the simulation. So in the initialization phase, you can see there is we define the number of users, calendars, and trace flag, and initialize the cloud sim entities. So here we define the data center because we need at least one data center to working on the cloud sim environment because we require at least one virtual machine. So one virtual machine can run on the one host and one host can be placed in the one data center. So we need at least one data center here. So here how to create the broker, I already tell the syntax. So this is the you can call the create broker function is there. I will tell how to create the broker. So this is the broker object is created. You can get the ID of the broker ID and store in the local variable. So here, so I'm going to explain how to create the broker and function how to create the data centers. So in the broker creates, you need to be just passing the name of the we need to be create the broker in the data center class constructor of the data center class. They assign the broker object to, and that is a return from here. So this function is used to create the broker. Now how to create the data center. So this function is used to create the data center where you need to be first create the host list and processing element list. Now here what happen? There is you create the processing element list and passing into the host. There you can see the processing element list on the virtual machine scheduling policies. Based on you can use the space shared also. So this function is create the particular on the data center passing the all informations. We define the structure, architecture, operating system, virtual machines, time zone, and the required informations here, and passing to the constructor of the data center to get the object of the data center, and that is a return from here. So these two functions are basically used to create the data center broker. Now here the virtual machines, we have created the virtual on the base of the this configuration. These to the virtual machine list, and this is submitted to the broker. So this is the syntax: the broker dot submit the VM list. Now in the next you have to create the cloudlet list, and this is the configuration of cloudlet list, and we need to be passing the cloudlet constructor here. So, and after that the cloudlet object is cloudlet list, which is the type of cloudlet. So here the cloud virtual machine are created. Now what you have to do, you need to be submit the cloudlet list to the broker. So this is the broker object where you need to be submits, and this is the function to start the simulation and stop the simulation. So start the simulation is initiating all the entities and component, and stop simulation is just flushing the all the entity and component and shutting down the cloud sim environment. Now there is a function for print cloudlet list of these received the executions results in the new list, and this is going to be sent to be the function of the print cloudlet list, and which is printed here in the specific format using these functions. So all the cloudlet are printed with these functions. So in the output example you can so here you can see the output of this execution program. So where the data center all entities are initialized, then all broker is created, VM0 is created on data center underscore 0, that is ID is 2. Now sending the cloudlet 0 to 0. So this is the I already explained that. So these are the results. In the result section you can see that the status is success and execution time in 160 units. So I'm going to explain another example. Just here you can see in this example with one hostage and run the cloudlet on two user on them. Means you need to create the two data centers. Every data center contain the one host, means we need to create the two hosts for each data centers, means one host for each data centers. And running the cloudlet of two users means we need to create the two broker here to run the cloudlet job particular task on that. So here we create the two cloudlet list, we create the two virtual machine list. In the program we set the two number of broker is there. Now we create the two data centers, data center 0 and data center 1. Now here you can see that we create the two users for two brokers with the broker 1 and broker 2. Then create the two virtual machine VM ID. So here VM ID is 0 is there. Another so this VM1 or VM2 is there, because VID is similar for both, because both are on the different hosts, so there is no conflict between the IDs. If we are creating two VM on the single host, there is a we need to be change the ID here. Then add all to the virtual machine list, right? Then this list is included into the broker. Then after that we need to create the cloudlets. So there is a two cloudlet is created, and both are submitted to the different brokers. So first one is assigned to the broker 1, and second cloudlet list is assigned to the broker 2. and both cloudlet is contain one cloudlet in this example. So we need to be start simulation and stop simulation. So both broker can receive the results in the new list 1 and new list 2. So we're going to the printing for the list 1, and here is going to printing for the list 2. So logs are printed. We run the example. This is the output. Two data. Now out it received the two resources, right? Two cloudlet is received. So it data center by the MIPS requirement. So it is created on the because it is a space shared environment. So no two VM created on the single data centers. So here you can see that the VM0 is assigned to the data center ID 0 because the data center is ID is started from the 2. We write the name is underscore 0 and one ID is started from 3. 2 start. After that, cloudlet is assigned to VM0 of data center has ID, and it is completely executed. Now you can see the separate results for of data center 2 executed on the VM ID 0 of the data center 2 and taking the time of 160 unit. In the you can see the output of the user 5 means broker second broker. There is a you can see the cloudlet ID is 0, status is success, data center 3. So these cloudlet of assigned to the VM0 of the data center 3, and there is a execution time is same because the configuration of the both are the same. So these first one is start on the 0.1 and completed in the 160.1. Then second is started from the 0.2 unit and completed in the 160.2 unit. So total both are taking the similar amount of time. So this is the example. You can download and install and see all the example. I already tell the how the cloud is work and what is the syntax of the cloud sim. This example is some provided some scalable environment where you can create the multiple virtual machines and multiple cloudlets and executed randomly on each one. So there is a lot of experiment you can perform here, and given the some 7-8 examples here, you can see and understand how cloud sim is work and how to simulate the cloud environment. And you can be develop your application before starting in the real world environment. You can be test on this simulation environment to analyze the performance here. Okay, thank you.
Sir, could you share your contact detail through which I can connect with you? Actually, I'm working on a project of Cloud SIM, so I need some help from you, sir.
Okay, so here I will write my mail ID, right?
Okay, sir. Okay.
Communicate me on. So you can see the my screen. I can write my
Yes,
mail
sir.
ID.
Hello. Any more queries from the audience? Yes, any more queries from the audience?
So it's too small. So it's Vikas Chauhan
.iitr@gmail.com.
Hello, is there any queries from the participant side?
No, no, man. Thank you, sir.
Sir, will CloudSim will support Python, sir?
No, Cloud Sim is implemented, so it not support the Python.
Okay. But what about CloudSim Plus, sir? I heard about some CloudSim Plus.
Yeah, Cloud Plus is an extension of the Cloud Sim. So there is a lots of extension of the Cloud Sim environment, just like a Cloud Analysis, the first one, and Cloud Plus and other many. So they are differently some extending this toolkit for their requirements. So cloud analysis is also implemented in Java, and I'm not explaining the cloud plus because there is a lots of extension of this cloud simulation. So once we have the knowledge of this cloud sim environment, we should to the real cloud environment using the Open Nebula and OpenStack. So nowadays, OpenStack is mostly used for creating the private and public cloud, and their document is available so everyone can explore. So why we are going to be more simulation, just be understanding the how the cloud sim environment will work. We should move to the real environment.
Any more questions from the participants? Okay, thank you, Vikas sir. On behalf of Information Technology Department, ICC Nagpur, I want to thank you for your insightful presentation on virtualization with case study and practical demo. We are really grateful for the time and efforts you took to share your knowledge and experience with us. Once again, sir, thank you for your contribution.
Yeah, thank
Now we will be having our next session at 12 p.m. Which is based on Introduction to Distributed System by Dr. U.A. Deshpande sir. After that, we are having next session at 2 p.m. Which is on Dependence Analysis and Parallelization by Dr. S.R. Sate from VNIT Nagpur. So be there at sharp 12 p.m. for the next
Ma'am,
session. Yes?
actually, ma'am, yesterday I'm not able to submit my response or feedback.
Okay.
So,
So that form is available, sir. You can submit it today also.
okay, ma'am. Okay. So
This
today link
is
will get
Mr.
in.
Lalit Kumar.
Yes, ma'am.
Yes,
Yes,
right?
ma'am. Yes, ma'am.
Okay, sir. We will accept your response. You can submit it today also.
Okay, ma'am. Thank you.
Yeah. Thank you.